to select the appropriate test, we're going to use the parametric test if it is normally distributed. And we're going to figure out what comparison we need to make. So in this case, our sample size is 15, so we're going to be doing the t-test. So now we need to figure out, if we run the test, how do we make the conclusion? So let me introduce this curve to the bottom right here. Does that look familiar? Where you have the normal distribution, and the computer's telling you that this is our test statistic. If you were to do the math, that t value would, for this data, is a drug trial. It's not related to the pumpkin pie filling, but it would be something like 7. The t would be 7. And so then what we're going to do is look up using the table that we're about to do, and we need to figure out, if we were to look up the critical value, where are we in relation to this red line? This is going to be the formula for the test statistic, okay? We're working toward calculating the test statistic so we can make the right decision here. But to make the right decision, we need to think about what these curves look like, okay? So we can take our alpha, and what that alpha means, remember the area under the curve, all of this equals 1, if you were to add it all up. Okay. And so what we're saying, like in this case, if we're doing a tail to the right, we're saying this is going to be 0.05. So what we're going to do is we're going to look up in the table of constants, what is this z or t value, depending on which test we're running. And then we're going to calculate that t or z statistic. And depending on which of these 3 scenarios we're running, like if we're interested in the first one, we're going to say, if the t value is more extreme than this critical value, then we're going to reject the null hypothesis. If the value is over here, though, we're going to accept the null hypothesis. Okay? So this is where I was saying it gets a little bit complicated. Are we working with a 2-tailed scenario, a 1-tailed, or where the tail is over here, or a 1-tail where it's over here? This slide is showing you, if all you care is whether they're different, then we're going to be spreading that 0.05 divided by 2. We're going to be using the 2-tailed because it could be different one of 2 ways. This one could be greater than this one, or this one could be less than this one. But if we want to know if the actual value is greater than the expected value, then we're going to reject it when our observed value is on this extreme of that critical value. On the other hand, if we're wanting to know if our sample value is less than the expected value, then we're going to be working with this one, in which case we're going to reject it if our t statistic that we calculated is on the extreme, if it's greater than that critical value. This is what we're doing for all of these tests. It doesn't matter which one you do. What we're doing is we're calculating a test statistic. This test statistic right here is whatever value we're comparing against this line. Whatever value we're comparing against this line. Where does that test statistic fall? Is it right here, in which case we accept the null hypothesis? Or is it over here, in which case we reject the null hypothesis? So we have a z test statistic, a t statistic. We have another z, a t, and a t. Okay? And notice for each of these, there's just some sort of numerator and denominator calculation, and it goes on and on. So the ones I put on this sheet are mostly t and z test statistics. You get them based on which hypothesis tests you're running different ways. And then we eventually, you can do a chi-squared, a chi-test or a f-test, but we probably won't get into that this semester. So